The objective of this lesson is to create a situational equation containing independent and dependent variables and graph information generated by the equation. In previous lessons, we learned a variable is a symbol that represents a number that is unknown. In real-world application, a variable can be anything that is not fixed or something that changes. There can be two types of variables in equations that show a relationship. An independent variable is considered the input. A dependent variable is considered the output. The dependent variable changes based on what value is placed into the equation as the independent variable. Let's look at the following example. While saving for an airplane ticket to Europe, Ira worked bagging groceries at the neighborhood market. He had $150 in his savings account for his ticket and adds $75 each month from his paycheck. The independent variable in this example is how many months Ira puts money into his savings account. The dependent variable is the total amount of money saved. The equation is 150 plus 75 times m equals t. We can create a table to represent Ira's savings at 0 months, 1 month, 2 months, 3 months, 4 months, and 5 months by using the equation and substituting the values in for the variable m. The values in the table can now be used as coordinate points. The dependent variable is the y-coordinate and the independent variable is the x-coordinate. On our coordinate grid, we need to label the x-axis and y-axis with values or our scale. We can look at the table to get an idea of the range of numbers needed. For this situation, the x-axis, which is the months, can be labeled in increments of 1. The y-axis, which is the total amount, can be labeled in increments of 50. We can now graph the pairs of coordinate points from the table. By looking at the table, we can see the relationship between the two variables. As the values along the x-axis increase, the values along the y-axis also increase. The y values are increasing in increments of $75. Let's look at another example. Boston worked this past summer mowing lawns. He charged $25 for each lawn mowed. Describe how much money Boston made mowing 5, 10, 15, 20, and 25 lawns. In this example, the independent variable is how many lawns were mowed, and the dependent variable is the total amount of money earned. The equation is 25 times L equals M. The more lawns Boston mows, the more money he will make. We can create a table of values using the amounts 5, 10, 15, 20, and 25 for L. We will substitute these values in for L to find the values for M. We can then use the values in the table to create coordinate points. We can look at the table of values to determine how to label the axes of the coordinate grid. We can label the number of lawns in increments of 5 and the amount of money he earns in increments of 50. We can now graph the pairs of coordinate points onto the grid. By looking at the graph, we can see the relationship of the lawns mowed and the money earned. Let's look at another example. A restaurant has 44 pounds of pasta in stock and serves the pasta 1/1800 pound per customer. Describe how much pasta is left in stock when 0, 60, 120, 180, and 240 customers have been served. In this example, the independent variable is the number of customers and the dependent variable is the amount of pasta left in stock. Since the restaurant starts with 44 pounds of pasta, the equation will be 44 minus 1/1800 times C equals P. We can create a table of values using the amounts 0, 60, 120, 180, and 240 for customers C. We will use the equation to figure out pounds of pasta, P, for each value. We can then use the values in the table to create coordinate points. We will label the x-axis with the values of 0, 60, 120, 180, and 240 with the number of customers. We will label the y-axis in increments of 4 pounds of pasta. We can now graph the pairs of coordinate points onto the grid. By looking at the graph, we can see that as the number of customers increases, the pasta in stock decreases. The objective for this lesson was to create situational equations containing independent and dependent variables and graph information generated by the equation. We met this objective by identifying the variables in the situation, writing an equation, filling out a table of values using the equation, creating the coordinate points from the values in the table, and then graphing the points on a coordinate grid. We then looked at the graph to determine the relationship between the two variables.